During this circuit, we check stability and frequency response on the circuit. Here we use this type to check it. And we get the frequency response of the bypass filter and not the filter is close to calculation. And here we get phase matching 65 degrees and here the matching is 43 as well. It is very good. It is safe matching to ensure stability of the system. And then we build it at the circuit and we get the result and we get the CCG waveform. Next, my friend, we talk about the XC filter and data transmission.
Thanks, man. So now we have the ECG signal. We need to first digitize it and then wirelessly transfer it to the iPhone. Here's the hardware component that we use to accomplish the task. The Arduino microcontroller for the ADC and the WT11 module for the data transmission. The Arduino microcontroller board has the 6 channels of 10 analog to digital converter. The input voltage in the range from 0 to 5 volts, and the converted value is an integer range 0 to 1023. So the resolution is about 4.9 millivolts per unit. It takes about 100 microseconds to read an analog. So the reading rate is about 10,000 samples per second. For the data transmission on Bluetooth, we use the logical link control and adaptation protocol with the baud rate of 115.2 bits per second. Because the Arduino board doesn't have hardware flow control pin, so we have disabled this feature on the module by connecting the CTS pin to ground and the RTS pin with loading. For security purpose, we use smart card to authentication process. This is the smart card reader that we use to read the smart card, which is from Omron, which has the TTL interface and operate at 4.5 to 5.5 volts. As you can see, the pin wiring diagram, Arduino with the reader. We need to connect to the pin data box and the load. The load pin, which is pin 4, is used for check if the smart card is currently inside the smart card. This is the timing sequence waveform for the Arduino. The very top one, CLB signal, is used for checking if the card is currently inside the smart card reader. The signal always go high when the card is talking to the reader. The signal go low and stay low until the card is injected. In the middle, CLB or RCL is the clock signal. Below that, RDT is the data signal. We read the data signal on the foreign edge of the clock. Whenever the RDT signal, data signal is low, the data bit is 1, and whenever it's high, the data bit is 0. When it comes to iPhone application development, there's only one choice for the IDE development tool, which is Xcode. The version we are using is Xcode 3.1.4 with iPhone SDK 3.1.2. In order to establish a Bluetooth connection, we need a Bluetooth stack running on the iPhone. The one we are using is BP stack, written by a guy named Matthias Greenwood. It's open source, and it is still in its development stage, early development stage, so it only supports the low-level protocol like L2CAP and interface of our iPhone application. It is really simple. Only the top one showing the patient ID, which is retrieved from the smart card. From here, and then transfer it to the iPhone via Bluetooth. And below that is the waveform that we retrieve from our device. It doesn't look as expected due to the data loss during transmission. Maybe because of the bandwidth of the Bluetooth module, or because we skipped the part about the hardware flow control. So now my teammate Giang going to talk about the part and labor cost.
The cost I'm talking about is part cost and labor cost. Total is $14,700. The part cost is about $100. It's only 2% of total cost. The labor cost is $14,400. Sorry, less than none. So the big problem we face is the noise. It's come from AC 60 of our line, and it comes from the biological noise of my laptop and keyboard. Of my laptop and keyboard. Calculation and simulation is very necessary for design circuit, but you have to verify the result. Actually, they are not exactly like a calculate and simulate. So you have to have the adjustment to get a good result. And when we do the DC board, if you solder the component on the DC board, remember that you have to test and verify it step as you go. Don't wait until the end, so wait time and money. And always give them the time and have a plan to have actual time before anything happens. Next is our demo.
So this is audio output our device. Now we turn on the ECG device. This is what we have on the oscilloscope. This noise. So we start the application on the iPhone. Now we start searching for the ECG device.